Hacking signals is pretty easy, especially like, electromagnetic radiation known as photons. Basically, you create a USB device that is like an ADC, which stands for analog to digital converter. So it takes the analog photons that wave like this, and they're really tiny, super tiny, and it measures them over an interval. You have to synchronize all of your waves to your input device to your computer. You create an array of input devices and use an IDE programming language to oscillate the input devices at a certain interval in basically pico or nano or micro or milliseconds. And when it turns it on, it measures the incoming photons at that given second on the voltage of, say, a copper wire loop. And since copper is sensitive to photonic energy and it creates ionized copper, it's a very slight ionization. It causes voltage to occur on a microcircuit, a sensitive enough transistor. And basically, in these complicated circuits, these microchips, they can read different voltages really fast. All you're really measuring is different volt amps at a very partition of a second. Very slight time frame. You're measuring lots of data, and then you loop it, and you continue to measure each voltage. And as it does that, it tells you every instance of voltage and frequency. If you have enough oscillation in your devices in your computer, and that's all in the gigahertz range. We're doing everything pretty well in the gigahertz range these days, but not every signal is actually in the gigahertz range. It's usually less than that, and signals can be higher than that. So, but most of the signals that we're using are in the gigahertz range, and that's basically how you hack signals. You create an array